Hello. In this video, I'm going to explain problem 16 from the 2015 F equals ma contest. We are given a graph of potential energy as a function of position and for a particular object, and we're told that the object has a mass of 0.5 kilogram. And we're asked to find which of the following statements is not true in the range shown on the graph between 0 and 6 centimeters. So, since we're given 5 different statements and we're asked to find which one is not true, really what we're going to have to do is just go through each statement and check one by one to see whether it's true. So the first one says the object could be at equilibrium at either x equals 1 centimeter or x equals 3 centimeters. Well, remember that what is equilibrium? Equilibrium means that net force equals 0 and net torque equals 0. And now in this case, we're just concerned about force, and since net force is 0, and remember, now what is the force? Well, force is negative the derivative of the potential. And so, even if you don't know calculus, you should at least know the idea that on a potential versus position graph, then the force will be the negative of the slope of the tangent line. So if I take a particular point and draw a tangent line like that is a very bad tangent line, sorry. Might look something like that. Then the slope of that, or the negative of the slope of that, would be the force at that point. And so, in general, this makes sense because basically the force, basically potential energy, comes as a result of working against a particular force. So, for example, potential, you have gravitational potential energy because, or like when you climb a flight of stairs, because you've worked against gravity. And so the force of gravity points downward, which points in the opposite direction of increasing potential energy. So that's just at least some intuition for that. So that means that for this derivative to be equal to 0, then that means that the potential function has to be flat. And indeed, that does occur at x equals 1 and x equals 3. And thus, statement A is true, and so that is not what we want. Now, statement B says the minimum possible total energy for this object in this range is negative 10 joules. Now, we're told the potential energy, not the total energy. But we know that the total energy is equal to the potential energy plus the kinetic energy. But what is kinetic energy? Kinetic energy is 1/2 mass times velocity squared. And so kinetic potential energy can be negative, but kinetic energy cannot be negative. And so the total energy is always greater than or equal to the potential energy. And so if the minimum potential energy in the graph is negative 10 joules, which it is in this case, then the minimum total energy will also be that same amount. And so, because you can always have the object lying at that point and having the kinetic energy equal to 0. So in this case, the minimum possible energy is the same as the minimum possible potential energy, because you can always have the object at rest at that point. So it's 0 kinetic energy. And so in this case, it is true that the minimum possible energy is negative 10 joules. Now we are told that option C, the magnitude of the force on the object at 4 centimeters, so let's draw 4 centimeters, this point, is approximately 1,000 newtons. So how would we do this? So remember that the force is negative the derivative of the potential. In this case, we just care about the magnitude of the force. We just care about the magnitude of this slope of the tangent line. If you just look at it kind of roughly, you can see that this line has slope roughly 1, and 1 in terms of these grid spacings. And so what is the force at that point? At 4 centimeters equals, well, 1 grid spacing in the y direction for the energy we can see is 5 joules, and the grid spacing in the x direction is 0.5 centimeter, And so that equals, remember, half a centimeter is 5 times 10 to the negative 3 meters. And so you actually will get 1,000 joules per meter, which is indeed 1,000 newtons. And so option C is also true. Now, how about option D? If the total energy of the particle is 0 joules, then the object will have a maximum kinetic energy of 10 joules. Now again, this goes back to this idea of total energy. So we're told that the total energy is 0 joules, and that will be U plus K. And so the object will have a maximum kinetic energy of 10 joules. Well, we know that U is greater than the potential energy is at least negative 10 joules by this graph. And therefore that means that the kinetic energy is less than or equal to, plus 10 joules. And so the maximum is indeed 10 joules, that if we have, for example, the particle with an total energy of 0 joules, and we send it to this point right here at the minimum potential energy, then it will indeed have that kinetic energy. Now we've seen that the first 4 are true, then the last one better be false, but let's check just to be sure. We're told that the magnitude of the acceleration of the object at x is 2 centimeters is approximately 4 centimeters per second squared. Now, once again, to find the acceleration, we should find the force. So what is the force at that point? So the force is equals 2 centimeters. And again, magnitude. And that's roughly equal to the slope of the tangent line at that point. Now in this case, what is the slope of the tangent line? Seems to be something closer to 2, or maybe somewhere between 2 and 3, but let's say it's roughly 2. And so we see that it'll be 2 grid spacings in the vertical direction. So it'll be, that's 10 joules. And then we divide by 0.5 centimeters again. And so basically that's just twice of what we had before. So 2,000 newtons. But we know that the object has a mass of 0.5 kilograms. And so the acceleration is equal to this force divided by 0.5 kilograms. So it'll actually be 4,000 meters per second squared, which is way, way higher than 4 centimeters per second squared. In fact, you can actually see that it's 100,000 times higher. And basically the reason is that basically here we actually have the potential energy changing over centimeters, which means that the potential energy is changing very rapidly. Because you're getting whole joules, but you're getting only fractions of a meter, small fractions of a meter. So you get U is changing very rapidly. And that means that the derivative, du dx, the force is very large. And so if the force is large, then the acceleration is large. And so it'll actually be much higher than the order of magnitude of just a few meters per second squared. And they're telling us a few centimeters per second squared. And so it ends up being way off. And that means that option E is the correct answer, because that's the one that's not true. And that's all there is to this problem. All right. Thank you for watching, and I hope that was helpful.